You may have heard a lot of talk about nanobots in recent days, and I think there is a lot of confusion because there's several fields all going on at the same time, and they're often reported as the same thing. So let's talk about what a biocompatible nanobot really is. Well, there's several different fields at play. There's the xenobots, which are constructed frog stem cells that can be put together in a form and can do a job. And then there's protocells. These are lipid membranes that are constructed in a way that looks very similar to bacteria and our cells. These are biocompatible with us because they can be made out of the husks of our own cells, so they're not activating the immune system. The process of making cells like these is kind of similar to making artificial life like Mycoplasma laboratorium, which is an organism that was made by constructing an artificial genome. Protocells require that we give them all of the nutrients and biological machines like enzymes that they require to do their job. We can use these in order to deliver medication to targets. And then we have the more complex nanobots. These often use a lipid membrane, but they're given specific tiny machines that allow them to move and be controlled. The activity of these tiny machines does resemble little enzymes, which are the proteins in us that perform different activities in our cells. It's not going to be easy to control them just the same way that we do something like a car. But if we can construct these nanobots, then we can ask them to do things like go after specific cancerous cells or deliver life-saving medication to areas of the body that are normally blocked off by the blood-brain barrier, like the brain. This could have huge consequences for things like genetic editing in people with genetic diseases that impact the nervous system. I do want to emphasize that lipid nanoparticles are not nanobots. They are not targeting and being asked to do a specific job. Lipid nanoparticles, like lipid-based medication delivery systems, are just a way to get it into your body. Oftentimes, molecules that are very large are hard to deliver in water, as water is polar and can interfere with structures in a medication.